All right, let's just jump right into this fascinating explainer. Today, we're exploring how science confronts unbreakable loops and paradoxes across entirely different dimensions. We're going to start way out in the mind-bending realms of theoretical physics and infinite mathematics, and then we're going to bring those exact same concepts right down into the actual biology of your own body. You'll see how nature, math, and even human physiology all kind of have this tendency to get stuck in these crazy, vicious cycles. But more importantly, we're going to look at how scientific innovation is actually figuring out ways to break them.
So let's kick things off with a story that perfectly illustrates a real-life paradox. Picture this. It's June 28, 2009, exactly 12 p.m. The legendary physicist Stephen Hawking is sitting in a beautifully decorated room at the University of Cambridge. There's a table absolutely overflowing with gourmet food, the champagne is poured, and there are these red, white, and blue balloons tied everywhere. Sounds like a great time, right? But the host sat entirely alone. Not a single guest showed up. Why? Well, because this wasn't a normal party. It was actually a highly calculated scientific experiment.
Here's the brilliant catch to Hawking's little get-together. He only sent the invitations out after the party was already over. He included exact GPS coordinates, the specific time, the whole shebang. They were essentially this permanent, open invitation to any future time traveler. So the fact that no one from the future showed up to drink champagne with Stephen Hawking, that was his elegant, real-world proof. It showed that while traveling forward in time is theoretically possible, say by hanging out near a supermassive black hole, traveling backward in time is a hard no from the universe.
And that elegantly leads us to the ultimate unbreakable loop, the grandfather paradox. It is literally the logical brick wall of time travel. Think about it. If you go back and prevent your own ancestors from meeting, you are never born. But if you're never born, well, who went back in time to stop them? It completely shatters causality. Plus, physicists have even noted that if you try to use a microscopic wormhole to travel backward, any radiation entering it would just loop back on itself. It would multiply infinitely in this fatal radiation feedback loop until the wormhole instantly collapsed. The universe literally protects itself from these logic-breaking cycles.
Okay, moving on to Section 2, Hilbert's infinite hotel paradox, breaking the rules of space and logic.
So, back in 1925, mathematician David Hilbert used this hypothetical hotel to show how infinity breaks human logic just as thoroughly as time travel does. Imagine a hotel with an infinite number of rooms, and every single one is occupied. You walk in, ask for a room. Now, a normal hotel would just turn you away. But the clerk at the infinite hotel, he just moves the guest in room 1 to room 2 to room 3, and so on. Bam! Room 1 is now yours. But wait, what if a bus carrying an infinite number of new guests arrives? Well, the clerk brilliantly shifts everyone currently in the hotel to room 2N. So the person in room 1 goes to 2, room 2 goes to 4, room 3 to 6, and suddenly every single odd-numbered room, which is an infinite amount of rooms, is instantly freed up for the new infinite guests, even though the hotel was already completely full. Crazy, right?
So how on earth is this possible? Basically, it's because infinite logic flat-out refuses to follow normal arithmetic. It all comes down to a concept called Cantor's transfinite number. In normal everyday math, a part is always smaller than the whole, obviously. But in the realm of infinity, a subset, like just the odd numbers, actually has the exact same cardinality, or size, as the entire set of all whole numbers combined. The paradox here is that infinity can absorb infinity without actually getting any bigger.
All right, Section 3, Law-Breaking Physical Anomalies. When mathematical models get stuck in loops.
Now, when scientists try to model heat transfer using traditional thermal wave models, especially when you have sudden jumps in heating or cooling, the math actually breaks. It literally predicts unphysical behaviors that violate the second law of thermodynamics. We're talking things that are physically impossible in our universe. To fix this loop, as a really fascinating 2019 thesis from Fingxia University points out, researchers have to apply Einstein's theory of relativity. By using a relativistic heat conduction model, we can actually correct the entropy production rate and satisfy the laws of physics. But there's a catch. It only works if the rotational speed of the virtual coordinate is greater than the speed of the heat waves. It's wild stuff.
Let's bring this closer to home with Section 4, the tired but sleepless paradox, vicious biological loops in the human body. You see, just as mathematical models can get stuck in unphysical anomalies, our own bodies can get trapped in biological loops. If you have ever stared at the ceiling at 2 a.m., desperately exhausted but completely unable to sleep, you know exactly what I'm talking about. But here's the thing. Insomnia isn't a lack of willpower. It's actually an evolutionary survival system that just refuses to shut off. Specifically, it's a malfunction of your HPA axis, the hypothalamus-pituitary-adrenal axis. Evolution gave us the system to dump cortisol into our blood so we could fight or run away from a saber-toothed tiger. But today's modern stress, it just keeps that alarm constantly ringing at night. That high cortisol actively suppresses your sleep hormone melatonin and keeps your orexin neurons firing. Essentially, your brain gets locked into a state of hyperarousal, absolutely refusing to let your guard down.
In this brilliantly, or maybe terribly, illustrates the relentless cycle of the tired but sleepless paradox. It just destroys our natural physiological clock. You're stressed, right? Which causes systemic inflammation. That inflammation fragments your restorative delta wave and REM sleep. And because you didn't sleep, your body panics and triggers even more cortisol to fight the inflammation, which just creates more stress, completely wrecking your ability to sleep the next night. It is a vicious feedback loop that's honestly just as destructive as that wormhole paradox we talked about earlier.
But don't worry, science has found a backdoor to break this cycle. And surprisingly, it's located right in your stomach, the microbiome gut-brain axis. Researchers discovered that a very specific probiotic strain, Limosilactobacillus fermentum PS150, can actually send signals directly up the vagus nerve highway straight to the brain. By using a specially heat-treated version, called a postbiotic, or HTPS 150, it stays incredibly stable while keeping all its biological activity. And unlike traditional sleeping pills that basically just knock you out and can actually deprive you of REM sleep, this gut-brain intervention naturally turns down that biological alarm. It shortens the time it takes to fall asleep and actually restores those deep healing delta brainwaves.
The clinical data on this is just incredible. A staggering 84.6% of subjects suffering from severe insomnia, meaning they had an insomnia severity index score of 8 or higher, experienced a measurable increase in their sleep hormone, melatonin, and a significant drop in their stress hormone, cortisol. We are quite literally breaking a biological paradox using gut bacteria. How cool is that?
All right, move into section 5. Breaking fibrosis vicious cycles, when healing turns to scarring.
Now let's transition to a much more dangerous biological loop, idiopathic pulmonary fibrosis, or IPF. In normal, healthy lungs, tissue repairs itself after an injury. But in IPF, the repair mechanism completely crashes. The cells responsible for healing, called fibroblasts, just go into overdrive. They deposit thick, permanent collagen scars until the lungs literally start to resemble a dry, stiff loofah sponge. This creates a terrifying, irreversible loop. The initial inflammation triggers the scarring, and then that stiff scarring itself triggers even more inflammation. It's relentless. And the grim reality is that IPF currently has a lower 5-year survival rate than many common cancers.
So how exactly do we break an irreversible loop like that? Well, back in 2014, medical science had a major breakthrough with drugs that targeted the fibrosis pathway. But because it only addressed half of the problem, it really only slowed down the lung deterioration. It didn't stop it. The new frontier of treatment focuses on a very specific target known as PDE4B. The scientific goal here is a dual strike, simultaneously hitting both the inflammation and the fibrosis pathways to completely interrupt the vicious cycle.
Let's break down exactly how this works on a cellular level, because it's fascinating. PDE4B is an enzyme, and its job is to break down a vital signaling molecule in our cells called CAMP. In immune cells, active PDE4B drives inflammation. In fibroblasts, it drives scarring. So by using medication to inhibit this specific enzyme, we prevent the breakdown of CAMP. This effectively forces the immune cells to stop causing inflammation, and it forces the fibroblasts to stop producing scar tissue. It is just a brilliantly elegant way to shut off two catastrophic feedback loops with a single biological switch.
And that brings us to section 6, escaping the loop, how science solves the unsolvable.
Take a step back for a second and look at the incredible journey we've just taken in this explainer. We started with Stephen Hawking proving that the fundamental laws of space-time prevent backward time travel. We looked at how infinite mathematics completely breaks standard logic and how physical models of heat can literally crash into physical impossibilities. But when we look at our own bodies, we see something truly inspiring. As the quote goes, while the laws of space-time prevent us from changing the past, scientific innovation allows us to break the vicious cycles of the present. We can't build a wormhole to fix the past, obviously. But whether it's hacking the gut-brain axis to cure a relentless insomnia cycle or targeting microscopic enzymes to halt a deadly lung scarring loop, science is actively learning to conquer the unbreakable loops of human biology.
Which brings us to our final thought. Science is all about identifying a wall, a paradox, or a vicious cycle, and finding the hidden door right through it. So, from the absolute limits of time travel to the deepest, most complex loops inside human biology, which paradox are you most eager to see science break next? Keep questioning, keep learning, and thank you so much for joining.
Knowledge grows through sharing. What are your thoughts on today's topic? Let me know in the comments below. Don't forget to subscribe as we continue to grow together.